This is psychological research. Psychology is first and foremost considered a science, and because it's considered a science, we do research. It's based in research, and everything a psychologist says is based on things that have been empirically verified. Here are some conditions that can exist in psychological situations. There's 3 things that can be considered pseudosciences, or things that make people think something is true when they really aren't. One of them being hindsight bias. You've heard the term before, hindsight is 20/20. People say that when they have someone who believes they knew the outcome of something before it actually happened, like they knew it all along. So if you think of a relationship, that maybe a marriage that a person enters into and you think, I don't think it's going to last. And 3 years down the road, you say you knew it all along when they get divorced. You knew that wasn't going to last. Hindsight bias. If you look back over things, you can realize that something was going to be true. Overconfidence is our ability to think we know more than we do about something. People are usually overconfident when they feel like they have a grasp of a concept. 82% of United States drivers consider themselves to be in the top 30% of their group. Most people think that they're a really good driver, when in reality, they could be overconfident. They could believe more in their abilities than they actually have. And lastly, the Barnum effect. The Barnum effect is the tendency of people to accept very general or vague characterizations of themselves. These things are also known as pseudosciences. It's like going to a palm reader or a psychic or reading your horoscope. When people say, oh yeah, that's true, that's me, those are all considered pseudosciences. Because we cannot really lump all people who were born in one day in one category. Can a person really read your palm and tell everything that's going to happen in the rest of your life? There are 2 different types of research. You can have applied research and basic research. Applied research has a very clear and practical application. It's something you can use. It usually has to do with a drug or a substance being tested for the treatment of something. Has a very clear purpose. All of the trials that took place for COVID-19, they are doing applied research. They're giving a group of people a substance, a vaccine, in hopes that it will treat or prevent them from developing the coronavirus. Basic research explores a question that you might be curious about, but it's not something that's going to be life-changing or useful. For example, if you want to study, I bet kissing changes as people age. You could study that, but it's not going to be life-changing. It's something that's interesting, but not life-changing. Most university research is basic research because students are coming up with ideas of things that they're curious about. There are 3 broad categories of research methods: descriptive research, correlational research, and experimental research. Descriptive research is mainly used to observe and record behavior. It includes case studies, surveys, and naturalistic observation. But there is nothing manipulated or changed during descriptive research. A case study is one type of descriptive research. It's when a detailed look at one person or a group of people is taken. It is describing what happens to that individual or those group of people. It's not going to give us any significant data about anybody else. But it can be important because if we can look at a specific group of people or one person who experienced something, it might tell us things that might happen to somebody else if they are in situations, or it might tell us some specific things that we can use in other areas. For example, Phineas Gage was a railroad worker who had a steel rod go through his frontal lobe and out his head, but he didn't die. He was the subject of a case study, and he was studied for many years to see how he as a person changed and how having that steel rod go through his head impacted him. His experience is unique because most people don't go through that, but it provided researchers with a lot of information about what your frontal lobe is responsible for. A survey is also a descriptive research method. It's the most common type of study in all of psychology. It does measure correlation, and it is very cheap and fast. And that's why it's the most commonly used. It's easy to just give a survey and have thousands of people take it. And perhaps you guys have taken some surveys through social media even, or SurveyMonkey. The thing with having a survey, though, is that you need a good random sample of people to make sure that you are completing an accurate survey. You got to have like thousands of people or at least hundreds of people. You can't have 20 people and have a good survey. Naturalistic observation occurs when a researcher watches people in their natural environment. They don't manipulate anything, and the person likely doesn't know that they're being watched. The thing about a naturalistic observation is because people don't know they're being watched, they probably will behave as they normally would, and there is not the Hawthorne Effect, which says that people change their behavior depending on knowing or if they know that somebody is watching them. But you can never show cause and effect with naturalistic observation because you don't know half of what's going on. All you know is what you see. The second type of research methods is correlational research. Correlation looks at relationships, naturally occurring relationship, trying to determine if one variable can predict another. There's nothing manipulated. The thing that you always have to remember when it comes to correlational research is that correlation does not equal causation. Just because two things have a relationship with each other doesn't mean that one causes the other. For example, let's just say that Dairy Queen is having their free ice cream giveaway. And it just so happens that on the news, they also say that there was a 50% increase in the number of people who were murdered. Can we say that eating ice cream causes people to commit murder? Like, can we say that there's a cause and effect relationship? No, we cannot say that. But perhaps there is a correlation. Maybe there's a relationship between those two factors. Because if Dairy Queen is giving away free ice cream, we know that not everybody who ate ice cream would become a murderer. So we cannot say that doing this will cause you to do that. You can have a positive correlation, a negative correlation, or a no correlation. A positive correlation occurs when variables go in the same direction. A negative correlation occurs when variables go in opposite directions. For example, the more you study, so if there's an increase in your studying, we also expect there to be an increase in your grades because the more you study, the higher your grades. That's a positive correlation. A negative correlation is when the variables go in opposite directions. The more you use drugs, the lower your grades. And here's what that would look like on a chart. For a positive correlation, we're going to have something that looks like this. So we're going to see an increase in both variables. For a negative correlation, we're going to see a decrease or the line pointing downward. No correlation means that these two variables are showing no similarities to each other. The third type of research is experimental research. It's the one that psychology is most concerned about because experimental research shows a cause and effect relationship. You do have variables that are manipulated, and you use something called random assignment. You try to eliminate pre-existing or confounding variables, and you have an independent variable. So let's talk about what those things are. First off, when you have experimental research, you have to make a hypothesis. That means that you need to express a relationship between two variables. It has to be something that's testable. A variable is anything that can vary or change in participants who participate in a study. If we say participating in class leads to better grades than not participating, and that is our hypothesis, we could actually go out and we could test whether or not students who participate in class have higher grades than students who do not participate. A null hypothesis expresses that there is no relationship between the two variables. The null hypothesis would be rejected if a relationship is found. An independent variable is whatever is manipulated in the experiment. It's hopefully what brings about the change. Most of the time, if you have a drug in an experiment, the drug would be your independent variable because that's what you're hoping will make a change. A dependent variable would be the effect of the drug, whatever you're measuring, because it depends on the independent variable. So for example, if we're trying to see if the Pfizer vaccine is effective in preventing the coronavirus, the vaccine would be our independent variable, and our dependent variable would be whether or not it has side effects and what happens as a result of that if the person develops the virus. The population in the study is the group of people who participate. You want your population to be representative of whichever group you're trying to study. So if we are trying to study whether or not a vaccine is effective in treating the virus, and we are trying to see if it's effective for people all over the world, then that means we have to give everybody in the world an opportunity at participating in the study. And that's where you'll see things like, hey, want to participate? Or you might have surveys or see billboards trying to collect people who agree to participate. A sample is the number of subjects that are drawn from the population. So once people say, yes, I'll participate, now you have a sample of subjects. And a representative sample is making sure that those subjects are included or representative of what you want to study. So you've got to make sure you have everybody from all over the world if that's what you're trying to do. Random sampling gives every person in the population an equal chance at being chosen. So that's why you want to make sure that you give every opportunity for everybody all over the world to know about this so that they can agree to it. Some will, some won't. Random assignment occurs after you've chosen your random sample of people. You then have to assign them to one of the groups in your study, either the experimental group or the control group. The experimental group is your group that's going to be exposed to your independent variable. So they're going to be given the treatment. They're going to be given the vaccine. Your control group is the group that's not exposed to the independent variable. They are not given treatment, but they think they are given treatment. They're given something called a placebo. A confounding variable is anything the researcher can't control that could impact the results of the study. So researchers have to do whatever they can to eliminate confounding variables. So if somebody is participating in a COVID-19 vaccine trial, then you want to make sure that the people who participate in your study are doing everything they can to not improperly expose themselves to the virus while they're participating in the study. So you wouldn't want somebody who's going out and partying and not wearing masks and doing all of these things that are high risk, traveling all over the world. You want people who are going to be trying to be careful as they're a part of this study. The placebo effect. So the people who are in the group who are not given the treatment could have what's called the placebo effect, which is when they think their condition is improving or they think they're safe because they think they've been given treatment, although they haven't been. Researchers also have to ensure that they are saying all of the research questions and presenting things to people who participate in the study in the same order to eliminate order effects. Sometimes in research, we could have what's called experimenter bias. That's where the experimenter influences the results of the study in a certain way. It's not something that they do consciously, but perhaps they're trying to get their hypothesis to be correct and they end up saying something they shouldn't. So the best way to prevent experimenter bias is to have a double-blind procedure. That's when the experimenter doesn't know if a subject is getting a placebo or if they're getting the real treatment. A single-blind procedure is when the subject doesn't know which group they're in, which that always happens. But a double-blind procedure is when the subject and the experimenter don't know which group is getting the treatment. If you guys watch the show Grey's Anatomy and you remember when Meredith did her Alzheimer's trial, she was supposed to have a double-blind procedure, and then she purposely allowed Richard's wife to be a part of the actual treatment group. She tainted the results of her study. An operational definition describes the actions that need to take in order for your study to be replicated in the future. So you have to define any terms that could be vague. For example, the word child. If you say that you are doing this treatment on children, you have to explain what you consider a child to be. Because for one person, a child could be somebody from birth to 18. And for another person, a child could be someone who has not yet reached puberty. The Hawthorne Effect can occur in a research study if a person changes the way they behave just because they know they're in an experiment. And there was an experiment at this Hawthorne Electric Company in the early 1900s where they were trying to increase worker productivity, and people naturally worked harder because they knew there were people watching them. If you have a good research study, it should be able to be replicated or repeated in the future. So as long as you have good information and good operational definitions in the future, people can replicate your study. The last thing we want to talk about regarding research are ethical standards. The IRB, or the Internal Review Board, makes sure that humans and animals are treated ethically in a research study. If animals are used in research, there must be a clear purpose. They must be treated in a humane way. They must be acquired legally, and they must suffer the least amount of suffering possible if they have to suffer at all. And we know in some cases, animal research is much more effective than having humans in research. For human research, people must be protected from harm. They must have privacy participating in the study. They must give informed consent and agree to participate. They must know that they can withdraw or leave the study at any point. Their information must be kept confidential. You can't talk about them. You cannot lie to them. And at the end of the research study, they have to know, what they participated in and resources if they need help in the future. The Tuskegee Syphilis experiment happened in the 1950s, and the goal was to see if Black people responded differently than white people to the syphilis, to having syphilis, and if it affected them differently. It was descriptive research. The treatment given was the treatment they were given for syphilis, and they were trying to look at the body's response. This very study was declared unethical and eventually shut down as more and more people started to die because they did not know, they did not give informed consent. They didn't know that they were being basically treated what they felt like as guinea pigs. Other health factors were some confounding variables, and for ethical concerns, they were lied to. They were withheld medical treatment even if they started to get sick, and they never gave consent. This study is the reason why a lot of people are hesitant with getting the coronavirus vaccine, because they feel like they'll be treated the same. That's everything you need to know about research methods.